All right, the homework that was due today was the January 2013 test question 62 through 68. This was another one where it's a little bit more information than I've taught you because they give you all the things you need to know in the reading and in the pictures. So answer 62 through 65 on these maps. The southwest corner of New York State has been enlarged in maps 1, 2, and 3. Arrows show the direction of the movement of the Allegheny River during different times during the Cenozoic era. The present boundaries of New York State and Lake Erie are shown on the map. Point A is on map 3, just represents a location in New York State. So we've got New York State. They blew up the little corner here so you can see which way the Allegheny River was flowing. Map 2 shows the course of the Allegheny River during a specific part of a geological time period. State the name of this geological period. Where do we even go about figuring this out? ESRT. Whoa. So in your ESRT, pages 8 and 9 is when we talked about time periods. So here's time periods, but where do I even start? There's a lot of time periods here. How long ago was this map a map of? 22,000 years ago. Where is 22,000? Well, remember, these go by millions of years. So there's 0 and there's 1.8 million. So 22,000 is in between there. It is in the Quaternary period. That is the only answer you could have had for question 62 is Quaternary.
I had Holocene.
Yeah, Holocene is the epoch, and they didn't ask for the epoch, they asked for the period.
Nice one, dummy.
Quaternary, I think is how you pronounce it. And that is a perfect example. Jake knew what he was doing, but didn't 100% read the words. And it said, name the period. Question 63 says, explain why the direction of the Allegheny River changed between the times shown on map 1 and map 2. So taking a look at these pictures, you can see the Allegheny River used to start down here and flow into Lake Erie. But on map 2, it still starts in the same spot, but gets its direction changed. Why did the map have to, or the river have to change directions? Because there's something in the way. A glacier was in the way. Glacial ice sheet blocked the river. Something along those lines, that the glacier got in the way. Did anybody word that? You want me to check how your wording was to see if it would have been accepted? All right, as long as it says something about the glacier blocking it. Now, question 64 is similar question, but it says, identify the present day feature that prevents the Allegheny River from returning to its earlier Neogene direction of flow to the northwest. So first of all, could you have put glacier again? Is the glacier in the way? No, because it says present day feature. There's no glacier here today. So what's blocking the river from making sure it doesn't go back the way it went? There is mountains. Now, those aren't really mountains. What does the key say they are? Nope. Glacial moraines. So let me see if I still have the answers pulled up here. Would they have accepted mountains? They would not have. We might have had to fight for you for mountains because there are some mountain ranges down there, but it was just that the moraines were in the way. And number 65, this one, you had to use your knowledge of earth science. It was not in the reading. The diagram in your answer booklet shows a partial cross section of the valley near location A on the map. On this diagram, draw a line beginning at X and ending at Y to show the shape of a valley after it was eroded by a glacier that flowed down the valley. Valleys formed by glaciers, what do we always say they look like? U-shaped. Yeah, that's all you needed was something that looked like a U. If your answer came to a point, I'd have to mark it wrong. So this one's wrong. It has to have a nice U shape to it. Question 66 was pretty straightforward. Just plot those. You do have to be very accurate when plotting. So I want to show you, I'll pull up the answer key to this. How it works is they give me a clear version of this answer, of this question, I should say. So they give me this clear copy and I put it over your answer. And it says that your answers have to be within these circles. All 9 of them had to be really close to exactly where they went. So you can see I get a little bit of wiggle room, but not much wiggle room for where the dots go. And the directions did say to connect it with a line. So if you forgot to draw the line, I had to mark it wrong. So you needed all 9 spots correct and the line had to be there. Back to the question. Question 67, calculate the rate of change from 2000 to 2010 of the average carbon dioxide concentration in parts per million per year. Calculate the rate of change. We did this for about 5 minutes back in October. So you probably don't remember off the top of your head. But anytime you hear the word calculate, what do you know to do? And that's math, right? Calculate means do math. And in this class, do we have to memorize the formulas to do math?
No.
No, this is not like memorizing all that stuff you have to memorize in the math class. All the equations are right here. So rate of change is the change in value divided by time. So the question said from 2000 to 2010. Well, in 2000, it was 370. And in 2010, it was 390. So how much did it change? How much? 20 parts per million. How long did that change take? 10 years. From 2000 to 2010 is 10 years. 20 divided by 10 is 2 parts per million divided by, or per year, sorry. 2 parts per million per year. Only answer that was accepted. No wiggle room on that answer. And they already did have the units there, so you didn't even have to include those. And finally, question 68 says, identify one greenhouse gas other than carbon dioxide that contributes to global warming. So first of all, if you had just stopped with identify only one greenhouse gas and you answered carbon dioxide, it's wrong because they already gave you that one. So it's another gas that's a greenhouse gas that we talked about last chapter. Methane's a good one. Water vapor is another good one. Those actually are the only 3 that I taught you about: methane, water vapor, and carbon dioxide. They did accept methane, water vapor, nitrous oxide, not just nitrogen. They accepted ozone, again, not just oxygen, but ozone, and chlorofluorocarbons. I only taught you the 3 to keep it simple. Carbon dioxide, methane, and water vapor are the 3 main contributors. In fact, I don't even buy that those other ones are greenhouse gases. They did other things. Those are the 6 questions you had for homework. Anybody need some more explanations on any of them? No? All right, so I asked you in your packet to turn to page 4, which you'll notice is a blank sheet of paper. That was on purpose. Everybody go to page 4 of your chapter 9 packet. Just a blank sheet of paper. Guys, what are the 4 seasons?
fall, spring.
So there are 4 seasons. And they are which one should we start with? Let's start with summer. Sorry, you lose, Jake. What season comes after fall? And then winter. And then spring. I don't care where you want to start. We started in summer because it was a fun season, I guess. My key is that you guys always need to know what season comes after the one you're talking about and what season was right before. So I know this seems like review from like what? Kindergarten, maybe even. But we'll go with 2nd grade if that's where you guys want to be. So this part was review, but this is also a place where people struggle because sometimes we get like what comes before summer and they always want to say fall, or what comes before winter and you want to say spring. So just know the seasons. I have no doubt that you actually do know them. You're just thinking or not thinking and just speaking sometimes. But then my main question is, let's compare summer, 2 M's, to winter. What is cold? So here's actually a perfect teaching point. Thank you. Always speak and write in a full thought. In science, I don't need you to do technically a complete sentence, but your answer was perfect. I knew what you're talking about. I didn't think you thought summer was cold, but we need a complete thought. Winter is cold, or at least colder. Summer is warmer. Good.
Isn't summer winter, winter dry?
So we do know the temperatures are different. No, there's no difference necessarily in water content in our area, at least. Sunnier, what do you mean by sunnier? Now this, okay, I think that's just the luck. I mean, there's a little more to it. Okay, hang on, guys. Oh, Kate, wait. The different dew point has to do with the different temperatures, but I want to talk about logistically, like, okay, yes, summer is warmer. Why is summer warmer? Okay, summer, and this is something we learned this year. The sun is higher in the sky, which is easier words for more direct. Remember when I was giving the examples of shining a flashlight in your eyes? In the summer, the sun is more overhead. It's higher in the sky, which again, in the winter will be the opposite. Sun is lower in the sky. What else about the sun do we experience in the different seasons? Now, when you say days, what do you mean by days? Days are longer. So yes, there's still 24 hours. I want to clear that up. But right, the sun is out longer. And if you needed to clear that up, you can. Sun is out longer. If you know what I mean by days, you don't need to clear that up. And again, days are shorter. You should be noticing, depending on how early you wake up these days, the sun's already up probably when you wake up in the morning, even for a school day, unless you're a really early riser. And it stays light. It's still light out when I go to get my kids at 8:30 for gymnastics. 9 o'clock, it's still not pitch black out yet. That is definitely not true in the winter. In the winter, It's still dark out. Like as you're coming into school, it's just rising. And depending on exactly when we're talking about, the sun's not going, or it's going down around 4 o'clock. These are the main differences between summer and winter that we need in earth science terms. Yes, of course, there's differences in cloudiness. There's differences in the amount of rain. These are the ones that are really important for earth science this year. This is what makes summer, warmer, because the sun's higher in the sky and the sun's out longer. In the winter, it's colder because the sun's lower in the sky and the days are shorter. So these you do need to know. Let's move on to page 5, which is what causes the seasons. Why is there a difference in the seasons? Can anybody? All right, so you're capable of reading, it sounds like. And we'll get the 3 reasons for the seasons. There's actually 3 reasons. There's nothing to write quite yet. The first reason for the seasons is the tilt. And we talked about this already, I think, but let's clear it up. Did you guys know the world was tilted? Okay, if you're gonna do that, that's your last warning. Just pay attention, okay? We don't need throwing or anything like that. Did you guys know the earth was tilted? Okay, if you didn't, and you just saw my globe up here, did you think it was just broken all these years, all these months? Okay, no, the earth is supposed to be tilted like this. It's leaning. It's leaning at 23.5 degrees, and that always points north. So that is the first reason we have seasons, is the tilt. So let's take a look at how that tilt affects the globe. And I'm just going to quickly use my little model here. I know it's not as exciting as so many of you wished. On this globe, how much of the earth is always lit up? Half of the world is always lit up. The side facing the sun is lit up. The other side is dark. Now you'll notice in this position, does that half and half? So if you can't see from where you are, I don't know if this will help, but if you can't see it from where you are, here's where that half and half is. Does it go straight down from North Pole to South Pole? No. No, it does not line up with the poles. So in fact, this is what's going to cause that differences in daylight hours. The tilt is making some places stay shinier or brighter longer than others. In fact, here's the North Pole. If the earth turns here, does that North Pole ever enter the day? No. It doesn't. The North Pole in this position is dark almost, no, I'm sorry, not almost, dark all day long. If I look at us, and I know again, you can't see us, but I just positioned the earth so it's, we in Buffalo are just coming into the day. And there it's already entering the night. In this position, the North Pole and us in the Northern Hemisphere get very little daylight. I know you can't all see it. Tyler, I think you can see it. Can you see the South Pole? Right here. As I turn this, does the South Pole even leave the daylight? Okay, in this position, the South Pole doesn't even leave the daylight. So the South Pole is getting 24 hours of daylight. The North Pole is getting 24 hours of darkness. Can you make a guess at what season this probably is then? This is winter. North Pole gets no daylight. South Pole gets 24 hours. We only get a very short period of sunlight. If I switch it to this position right here, again, here's that half and half mark. If I spin the earth, does the North Pole leave the daylight? The North Pole stays lit up in this position all day long. The South Pole is dark all day long. What season do you think this is? This is summer. Without the tilt, we wouldn't get, in fact, let's go to this one. I know you won't be able to see it, but now where does that half and half line up perfectly with? Right with the North Pole and the South Pole. If we didn't have the tilt, that's how it would be all year long. The side facing the sun is perfectly lined up with the North Pole and the South Pole. So it's split right down the dead smack center then. And everybody in the world would have 12 hours of daylight, 12 hours of darkness all day long. That's without the tilt. So without the tilt, we'd be stuck in that 12 hours of daylight, 12 hours of darkness. Rises at 6 a.m., sets at 6 p.m. So the tilt causes different latitudes to have different amounts of daylight. And you should know that if we have more daylight, we'll have warmer temperatures. So without the tilt, we'd be stuck with that 12 hours of daylight, 12 hours of darkness. Especially those of you who either have a farm or grow gardens. We need those longer days to get our crops growing. So we'd be stuck with that shorter days. Might still be warmer, but we'd still have shorter daylight hours. Even my chickens wouldn't lay as many eggs with only 12 hours of daylight. Now, the next reason is the revolution of Earth around the sun. What does that mean, revolution of the Earth around the sun? No, it does not mean it rotates. Okay, so review, what does rotate mean?
Spinning on its axis.
That's rotating. That does not cause the seasons. It's the Earth going around the sun that causes the different seasons. What would happen if the Earth was just stopped and it didn't go around the sun?
There would be no seasons.
There would be no seasons. Now, would we have a different season than the Southern Hemisphere?
Yeah.
We would. If we were stuck in this position, this would be our summer because the Earth is, if we tilt, we see the North Pole will always get daylight, and it would be their winter. So there'd be different seasons around the globe, but if we didn't revolve, we'd be stuck wherever we were. So if we were stuck here, it would be summer. If we were stuck here, it would be our winter. So we'd be stuck in whatever season we were in. So without the tilt, we wouldn't have seasons, or without the revolution. You have to have both of them. So the revolution of the Earth around the sun just means the Earth going around the sun. The last one is a concept you probably never, ever, ever heard. It's called the parallelism of Earth's axis. Doesn't that sound like a word that I make up, like oval-ish? Parallelism. What word do you hear in there? Okay, parallelism of the Earth's axis means the axis is always parallel. It never changes its direction. It's always pointing north in this point. So I'm going to demonstrate again what that means. So that means the axis is always parallel to itself. Here actually, let's start here. What season again am I in if this is the sun and this is the way the earth is? This is summer. Then I'm gonna go over to winter. Notice, let me start back at summer. Where is the axis leaning towards in my classroom? Towards the windows. How about here in winter? Still in winter. How about here in which is spring? Window. How about here in fall? Window. That axis, if I was able to stop, kind of like I just did here, I have this one here and this one here. Where are both axes pointing? Windows. You notice how this line would be parallel to that line? The axes are parallel to each other, no matter where they are in the trip around the sun. They're always parallel to each other, meaning they always point north. If they didn't, and for example, the earth revolved by always pointing towards the sun, we'd be stuck in our summer. South Pole would always be stuck in winter. So the fact that the axis always points towards the windows is the reason why we get our different seasons. So without that, we wouldn't have seasons. You need to have all three of these to be true to have seasons at all. Couple of vocab words. Solar noon is when the sun has reached its highest point in the sky. Remember, it is not necessarily when the sun is directly overhead. It's just when it's highest in the sky. You guys have all taken an art class in your life, right? What do you know about shadows? Okay, versus other darker areas. You know what a shadow is. It's always opposite the light source. So whether you're in a photography studio or you're drawing a picture that you need to have a shadow in, wherever the light source is, the shadow will be opposite that. So in terms of the sun, the shadow is always opposite where the sun is. So if the sun was behind me, my shadow would be in front of me. You guys know that. You've experienced shadows before. How about length of shadows? When is your shadow really long when you're outside? Sunrise or sunset? When the sun is low in the sky, we're going to have long shadows. And when is your shadow just itty bitty? When the sun is higher. Remember, it never gets directly overhead. In fact, if the sun was directly overhead, how long would your shadow be? Because you wouldn't have a shadow. It would be right underneath, just whatever's missing. So shadows are always longer when the sun is lower in the sky, higher, and direction always depends on your latitude. All right, we're going to skip the next two bullets and go right to the back. What is that, page 6 then? As this page says, it says the diagram below illustrates Earth's position at the beginning of each season. Draw it says, draw the lines on Earth to show the movement around the sun throughout the year. Label the seasons and the date it begins, location on Earth where the sun's vertical rays are, and the amount of daylight in the northern hemisphere for each of the positions. What we're going to do is we're going to put some notes on here. So the first thing is, I want you to realize, I know this looks like, it almost makes it look like the Earth's going around this way. But remember, this is trying to put a 3D shape onto a flat piece of paper. So what we've got here is it this one? It's really the sun in the center with the Earth going around it, just like this, in a flat space. So my question to you is, can you easily point to summer? In fact, actually, let's label this so we don't get it confused. Let's call this one on the left A. And then go down and around, following the arrows C and D. Can you look at this fairly quickly and decide which one is summer? Some of you are nodding. How will you tell which one's summer? It's whichever one the axis is tilted towards the sun. And that's location A. And I actually have an easy way to remember this. Have you guys ever heard the phrase sun worshiper?
No.
Okay, what do you think a sun worshiper does?
Worship sun.
Worships the sun. This is actually something that would be referred to as somebody, probably a lot of us are actually sun worshipers. We really like to go out in the sunshine. As soon as the sun comes out, we're out there, especially around here in Buffalo where we haven't seen it most of the winter. We're like, thank goodness the sun is here. Okay, few of you at least are buying that concept. Now, when you think of worshiper, what do you think of? Somebody who's worshiping, what are they doing? Don't think science. Where do you go to worship?
Church.
Church, or whatever religious organization you believe in. And when I think of praying, I often think of bowing your head. Does that make sense? Bowing. Do you see where I'm going with this? Doesn't it kind of look like the sun is, or the earth is bowing to the sun? That's how I remember it. In the summer, the earth will always be bowing or worshiping or praying towards the sun. That's how I remember it. Now, I'm not putting any real religious meaning to this, so don't come after me. Okay, this is not really church. I'm just showing you that's where my head goes here. The earth is bowing, praying, whatever you want to think of, towards the sun. That's summer. Now, how do I figure out the rest of them? I go, if this is summer, what's directly after summer or directly opposite of summer? Winter. So if I know this one's summer and this one's winter, what's this one? And here's where you got to remember, put them in order. After summer comes what before winter? This is fall. So see, obviously, you know what season comes next, but in your head, you don't stop and think long enough. So spring. So you do need to be able to do that. You need to be able to point to one of these and tell me what season it is. So now we're going to do the rest of the notes that go with summer. So, we're actually going to start with spring. So up in this upper left-hand corner, put an arrow here showing that that's what's called, the first day of spring is really called the vernal equinox. That just means the first day of spring. Vernal. You do need to know the date, March 21st. This happens when the sun is located directly up, or the direct rays of the sun will be hitting at the equator. So remember how I talked about direct rays? That's when the flashlight shines directly in your eyes. On the first day of spring, the sun is shining directly over the equator. The entire world will get 12 hours of daylight and 12 hours of darkness. Equinox is the first day of spring. You should notice equinox starts with EQU. Means equal hours of daylight. And not only that, we also have the equator. So equal, equinox, equator, or equinox, equal, and equator. So that's, you do need to know all three of these bullets. It's not in your reference table anywhere. All right, moving on, we're gonna go over to summer. So put these notes in the bottom left corner if you have some room. Again, making sure that you know that this one is summer. Now, is the world in your way, Renee? Is that some metaphor for something? The summer solstice, so notice it's not called the equinox anymore because nothing's equal. This happens on June 21st. Sun is going to be directly overhead, the Tropic of Cancer. And this is our longest day. In New York State, we get about 15 hours of daylight. Remember, this is only summer for us in the Northern Hemisphere. It's actually winter in the Southern Hemisphere. I know I'm moving kind of fast. We're going to move on to fall, which I hope you guys all know is also called autumn. Yeah. Okay, good. It's officially called the autumnal equinox. You can call it the fall equinox, or you could even call it the first day of fall. On paper, it's going to look exactly the same as spring. So again, make sure you know which one this is pointing to. So the autumn one. You really can't tell the difference between spring and fall on paper. You have to look to see what comes before and what comes after. I know I'm moving fast. I'm going to put the last one up for you to copy. Winter solstice. So again, not an equinox because nothing is equal. This happens on December 21st. The sun is directly overhead the Tropic of Capricorn. And this will be our shortest day of the year. This is when we only have 9 hours of daylight. When you are done taking the notes on this page, meaning you have all 3 bullets for all 4 spots, you can pack up. We're not going to have homework, but keep in mind, we're going to have a test on Wednesday. We're cutting it pretty close to getting all of the stuff learned by Wednesday. But I think it's time to move on.